Hello class, in this video I'll be applying the law of cosines to find the missing sides and angles of a triangle. Well, let's begin. So I've already gone ahead and drawn the picture, and side length A is equal to 2, side length C is equal to 4, and angle B is equal to 45 degrees. All of that is labeled blue. What we are trying to determine is labeled in red. And before we begin, let's determine which geometric property of triangles is displayed here. So it looks like we are given a side, another consecutive side, and the included angle, or the angle between the two sides. So that is side angle side, which implies only one triangle is possible. Okay, so now that we know that only one triangle is possible, let's apply the law of cosines to figure out all the missing side lengths and angles. And we're going to start with side length B. And we can do that because we have side length A, we have side length C, and we have angle B, which is the information we need to apply the law of cosines to find side B. So B squared is equal to 4 squared plus 2 squared minus 2 times 4 times 2 cosine of 45 degrees, which implies that B is equal to plus or minus the square root of 4 squared plus 2 squared minus 2 times 4 times 2 cosine of 45 degrees. Now, since we are dealing with side length, we're going to ignore the negative solution and focus on the positive solution. And we're going to evaluate that square root in Desmus. So notice that I've already have the square root expression entered into Desmus. And I just want to make sure that I'm in degree mode. So hit the wrench, and yes, I'm in degree mode. That's good. So it looks like the side length B is approximately 2.947, but we're going to round that to 2.9. Okay, so that is approximately 2.9. So now, this is where a lot of people would now switch to the law of sines to find angle C and to find angle A. However, I don't like that approach because if we apply the law of sines now, you might come into an ambiguous situation, and I don't want that. So we're going to apply the law of cosines again, and since we have three sides, side, 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 we're going to find the largest angle first. So in this case, the largest angle is opposite of the largest side. So we're going to find angle C. So angle C. Applying the law of cosines, angle C can be found by the following. That'll be 4 squared is equal to 2 squared plus 2.9 squared minus 2 times 2.9 cosine of angle C. Next, I'm going to isolate cosine of angle C, and that's this. And to isolate C, to determine what angle C is, I am going to take the inverse cosine of both sides. So angle C is equal to this inverse cosine expression, which we're going to evaluate in Decimus right now. So I've already gone ahead and entered the inverse cosine expression into Decimus, and I know that we're in degree mode, so angle C is going to be approximately 108.02 degrees, or 0.3. However, we're just going to round that to 1 decimal spot, so that'll be 108 degrees. And finally, we can figure out angle A. So angle A is going to equal 180 minus the sum of the other two angles. So angle A is equal to 180 minus 153. So angle A is going to equal 27 degrees. And we are done.